In this tutorial video, we shall discuss on statistics and we'll be taking questions of this sort. From the given question, we are asked to compute the mean of the difference. We also asked to compute the standard deviation of the difference in this question given. Form a hypothesis, calculate the test statistics and critical value, then make a decision. So this is the kind of question given. The data here shows the blood pressure of 10 patients before and after treatment. So we are asked to find the mean of the difference, that is before and after. For we to do that, we move over to this side of the board. We say solution. For more on this topic, you need to subscribe to this channel. Before we go about it, we first rewrite this table. We make out this table out. So the table we'll have first is the first on the list is patients. Patients. The next on the list is before. After, which is our y value. We'll also find d, the difference. That means x minus y. We'll find b squared. So these are the different columns we'll have for the given question. These are the different columns we'll have. Now, first, we'll rewrite this out properly. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We'll have the next one, 150, 150, 142, 160, 155, 130, 138, 145, 155, 140, and 148. The next we have 140, 135, 150, 150, 125, 130, 138, 150, 135, and 140. Now, to get the difference, we say x minus y, 50 minus 1, 150 minus 140 is just 10. 142, 142 minus 135, we have 7. 160 minus 150, we have 10. 155 minus 150, which is x minus y. 155 minus 150, we have 5. 130 minus 125, we have 5. 138 minus 130, we have 8. 145 minus 138, we have 7. 155 minus 150, we have 5. 140 minus 135, we have 5. And 148 minus 140, we have 8. So that is it. Then for the d squared, we have 10 squared, which is 100, 100, 49, 100, 25, 25, 64, 49, 25, 25, and 64. So this is what we have. Now, we will now have to write the mean, the formula for the mean, so that we can be able to compute it easily. For we to do that, we move over to this side of the board to do that. So we have to delete this first. For more on this topic, you need to subscribe to this channel. All right, we have that of the mean A. The mean of the difference. The mean, which is denoted as this, will be equal to summation of D all over N. Now, what is N? N is the number of observation. Here we have 10. So here, N is equal to 10. What is summation of D? Summation of this is D. So we solve the whole of this. What will it give us? We solve the whole of that. We have 10 plus 7 plus 10 plus 5 plus 5 plus 8 plus 7 plus 5 plus 5 plus 8. So we have 70. So summation of D is equal to 70. Summation of D is equal to 70 and N is 10. Now, what does it mean? It means that we have here 70 divided by 10, which is equal to 7. So our mean is 7. Therefore, the mean is 7. So the mean of the difference between X and Y is what? 7. Now, the next question here, we are asked to calculate for the standard deviation, that is B. The standard deviation, which is denoted as SB, is equal to the standard deviation of the difference, or the standard deviation of B, can be written as square root of summation of B squared minus summation of B all squared all over N divided by N minus 1. Now, what is summation of B squared? We haven't gotten that one. We have to move over to this other side of the board to do that. Now, the whole of this, B squared, we have 100 plus 49 plus 100 plus 25 plus 25 plus 64 plus 49 plus 25 plus 25 plus 64. So we have summation of D squared is equal to 526. Summation of D squared is equal to 526. We know our value for N. So summation of D squared, we know our value. So we cannot calculate for the standard deviation. We cannot calculate for the standard deviation. So we have to delete this side of the board. Sorry. The next one is form a hypothesis. Delete it. For more on this topic, you need to subscribe to this channel. Now, we have this to be equal to square root of summation of z squared. We have 526 minus summation of z all squared. Summation of z all squared. Z here, we have 70 squared divided by n is 10 all over n is 10 minus 1. N is 10 minus 1. You still have to delete this other part of the board. We'll come to it later. This is equal to now 70 squared divided by 10. 70 squared divided by 10. We have square root of, okay, to make our work easy, we say this is equal to square root of 526 minus 490 divided by 9. So 526 divided by, 526 minus 490 is equal to 36. Square root of 36 divided by 9, which is equal to square root of 36 is 6 and square root of 9 is 3. So 6 divided by 3 is 2. So our standard deviation is equal to 2. So we have succeeded in calculating for the standard deviation, and we have also succeeded in calculating for the mean of the difference. We succeeded in calculating for the standard deviation. We succeeded in calculating for the mean of the difference. We have the mean of d to be 7. We also have the standard deviation of d to be 2. Now, the next thing for me to do is to form the hypothesis for this case. We form the hypothesis for this question. So we delete one other part of the board to do that. Because of space, we'll also use this part of the board. We'll use this part of the board to do this because of space. So we delete this. So the C part, we are asked to compute the hypothesis. We are asked to compute the hypothesis. The C, the hypothesis. Now, we can put our H naught to be equal to mu d, which is equal to 0. We can say No difference in mean between, we use these two to form our hypothesis. So we say no difference in mean blood pressure before and after treatment. No difference in mean blood pressure before and after before and after treatment. We also write our alternative hypothesis, which is not equal to D and is not equal to 1. Here we say there is difference in mean, there is difference in mean there is difference in mean blood pressure before and after treatment. There is difference in mean blood pressure before and after treatment. So this is our hypothesis. We have succeeded in forming the hypothesis. The next on our list, we are asked to calculate for the test statistics and critical value. We have to calculate for the test statistics and the critical value. Now, what is the test statistics? B. Test statistics. Our test statistics can be written as C to be equal to G minus mu G all over SD minus, sorry, all over square root of n. Of course, we have all these parameters, all these are parameters as our base and score. We have looked for them already. We got our standard deviation to be 9. Okay, we got our standard deviation to be 2. Our standard deviation to be 2. And we got our mean to be 7. Our mean to be 7. So our mean is 7 minus, this is 0 all over, our standard deviation is 2. We got it to be 2 divided by square root of 10. So our test statistics is equal to 7 minus 0, which is 7 all over 2 divided by 10. 2, sorry, divided by square root of 10. We have 0.632. So our test statistics will be 7 divided by answer, which is 11.07. That goes with. So these are our test statistics. Now, the next thing we have to find is the critical value. But we found the critical value, we can also look for our degree of freedom. We look for our degree of freedom. Our degree of freedom is just n minus 1. So it's very simple. So before the critical value, we look for our degree of freedom. So we still use this other part of the board to do that. We first find our degree of freedom, then we find the critical value. Now, we'll delete this part C. Our degree of freedom is equal to n minus 1. The n minus 1 is just 9 minus 1, which is, sorry, n is 10. n minus 1, so our dn, which is degree of freedom, is equal to n minus 1, which is 10 minus 1, because n, we got n to be 10. So 10 minus 1, which is equal to 9. So our degree of freedom is equal to 9. Now, we also find our critical value, critical. This will enable us make our decision. Our critical value, we have to look for our critical value. Of course, we know that this is a two-tailed statistic question. It's a two-tailed statistic question. So, we delete this part of the board. All right. So, our critical value, we can say for say 5%, which is 0. Of course, you know it's a two-tailed. For 0.05, two-tailed, and degree of freedom to be equal to 9, we have that our test statistics for 0.05 and degree of freedom 9 is equal to, we have to check our table. In our table, we will have 2.262. 2.262. 2.262. Now, what becomes our decision? Of course, we know what we got on our T statistics to be 11.08. So we compare it with this. So it don't mean that since, we can say since our T calculated is equal to 11.08, which we got, since it is greater than 2.262, which is our critical value, which is our T critical. All we need to do is that we reject H naught. H naught. What did we say is H naught? No difference in mean blood pressure before and after treatment. So since our test statistics calculated is greater than our test statistic critical value, which we also calculated, we reject H naught. We reject H naught. And that H naught means there is no difference in mean blood pressure before and after the treatment. So this is how we can compute our statistics. This is how we can compute questions of this sort. For more on this topic, you need to subscribe to this channel to get more tutorials on statistics.